But this sensor, because of wind, wind, temperature, sensor senses 5 degrees. Then you're gonna get this message. For the E2, whenever you have a difference more than 5 degrees, you're gonna get this message. For the E1, how don't we see this message on the E1? Because on the E1, the threshold is 11 degrees. That's why on the E1, we hardly ever see this situation. But for the E1, it's 5. For the E2, it's 5. So the procedure, there is no issue. The procedure is just to, after 30 seconds, it's written here, 30 seconds after the second engine start, just to reinsert data on the takeoff data set. Press enter and check the ICAS if everything is okay. All the information is according to the E-curve. It's only this situation, this procedure. Wait for 30 seconds after the second engine start, reinsert the takeoff performance on the TRS page. Takeoff 3, temperature, flex, activate, check on the ICAS. Okay, everything is okay. You can go. Okay, but it's not a failure. It's not a failure. We have a limitation for the oil temperature. We have this message on the ICAS. It's written on the AOM that the oil temperature must be above 49 degrees. Okay? But in fact, this temperature is based on the temperature, the outside temperature, and the fuel tank temperature. So imagine that on the winter time here, minus 40 degrees, minus 40. Minus 40 is around here, right? And the fuel tank maybe around minus 29 degrees. So to get this message here, the fuel temperature in fact must be around 30, almost in the limit to get this message. So in a hot temperature, we hardly ever have this message on the engine warm-up. Hardly ever. But it's just a matter of wait. Wait for the message disappear and you may take off. We cannot take off on this airplane with this message on the ICAS. We have to wait for the message to disappear to get inside within the limits of the temperature. Okay? This is wrong. I'll talk about later on regarding the thrust reverser. Ice speeds. Let's talk about ice speeds. So we can face two conditions to get the ice condition and stall protection ice speed on the ICAS. Whenever you get through an icing condition, an area that we have really ice, and the ice detector sense that we have ice, then the airplane will trigger the ice condition and stall protection ice speed, open the valves and start working to melt the ice on the airplane, okay? But we may face a situation that we are flying in KOK situation, 30 degrees Celsius in Brazil, in Rio de Janeiro, and we can get ice. This message. No clouds because of this undetected envelope condition. So what it means for protection, whenever we are flying in a situation that is pretty similar to an ice condition, that the airplane is, all the sensors of the airplane sense that the airplane is with a degradation in performance, which means low rate of climb, any speed that doesn't match with that rate of climb, temperature, outside temperature, they will trigger as a protection the ice condition. So Sometimes in Embraer, we are doing the delivery flights for you, for the customers, and sometimes the ATC asks us to maintain a certain speed and climb with 1,000 feet per minute. And sometimes the pilots select 300 feet per minute, flying with 250 knots, and after 2 minutes, we get this message. Okay situation. So the system says, oh, this guy is flying with 250 knots, 300 feet per minute. There's something wrong. There's something wrong. So the airplane enters in the undetected ice envelope. There is no ice, but as a protection, it will activate the anti-ice system. Okay? So if you face a situation like this, good weather and get ice condition, maybe we are flying in an envelope for ice, for normal ice. Okay? Then you'll be triggered this as that's a big deal. After you select a climb rate, a normal climb rate, a normal speed, it goes away. Okay? And you have to reset the stopwatch ice speed. Okay? Because the stopwatch ice speed will be keep there until you reset it. And the conditions to reset the ice conditions, the stopwatch ice speed, SAT plus than 5 degrees at or above, and ice detector are not detecting icing conditions, which means I have to see only on the ICAS stopwatch ice speed. If I'm seeing icing condition there with the stopwatch, I cannot reset, because if I see icing condition, it's icing condition. Okay? There's no way to reset it. But if I have only stopwatch ice speed, and I can reset, as long as I have this situation. Just wait for the SAT. On the map page, we have the information regarding the temperature. So 5 or greater, you may reset. And the stopwatch speed will disappear, and you may land with normal speeds as you calculate on the perf. Needless to calculate with stopwatch ice speed. Okay? Having that said, let's have an assessment regarding resetting stopwatch ice speed. So we are briefing to descend to land here in Ulaanbaatar, and the 80s states that we have 10 degrees Celsius on the airport. 10 degrees. When you ask for approach checklist at 14,000 feet, 13,000 feet, anyway, I read the approach checklist, special the science panel set, ice speed reset, and I watch the map page, minus 3 degrees. I cannot reset at this time. I have to wait. 5, right? 5 or greater. And altimeter setting cross check. In a certain point, I will reset, because the temperature in the airport is 10. I'll be greater than 5 in a certain point during my approach, right? When? My suggestion, remember that we have these rules of thumb. For every 1,000 feet, the temperature decreases 2 degrees Celsius. So if I have in the 80s 7 degrees, I calculate for ice speed. So as not to be worried on the final approach, on the short final approach, to reset the speed. You know what I mean? So I would plan to land in normal speed, because I will reset as long as I have at least, what is the final fix is around 1,500 above ground level, right? Let's round up to 2,000. 4 degrees, according to this rule of thumb, right? If I have at least 8 to 9 degrees on the airport, then I plan to reset. If I have less than that, if I have 6 degrees on the 80s, let's do with stopwatch ice speed. Let's calculate for ice speed. Okay? So as not to be worried about resetting speed on the final approach. Remember that the final approach is a critical phase of flight, right? We have to be concentrated on the final approach. So it's just a suggestion. Okay, just a suggestion. I see many at the beginning when I provide support. I say no, let's reset the IC speed because it's 6 degrees in the airport. We won't be able to reset on the short final approach. Why? Let's calculate for IC speed. It's around 2 or 3 knots greater than the normal speed. This is a CRM, right? This is CRM. But we have to know the system, the design system, right? Got it?
Question.
Yeah?
Going back to the undetected ice envelope. On the E1, it doesn't show ice conditions to ice speed, right? It just shows anti-icing involved.
Yeah.
Because it depends on the FMS load or something, because we have 2 E1s, right? One of them doesn't show undetected ice speed.
No, on the E1, we don't have this kind of feature. Undetected ice speed. We have a test at 10,000 feet.
Really?
On the E1, whenever you cross 10,000 feet, around 10,000 feet, okay? Around 10,000 feet.
Yeah.
The system does a test.
Yes.
It's a test. It's not an undetected ice speed.
We know, but the problem is when we are descending, right?
Yeah.
Out of the cruise, sometimes the NTS wind opens on one of the aircraft.
But in a good weather, with
perfect.
no icy condition, maybe it's an issue.
It's been happening for a while.
Yeah, maybe we have to write down on the log, on the tech log, and ask for the technicians to look into this situation, because it's not normal. If you don't have ice, because on the E1 we don't have this feature, undetected ice speed. We don't have. It was an improvement for the E2. Okay? Yeah. There is no undetected ice envelope for the E1. Let's talk about alternate CG. So this is just a matter of certification. Alternate CG. Okay? Why do we have alternate CG? Look, according to the FAR 25, it's a regulation regarding aircraft certification, commercial aircraft certification. To get the takeoff performance, test pilot has to consider the worst of this speed for takeoff calculation, for takeoff performance, sorry. Okay? And sometimes the worst is stalling speed right after takeoff and minimum control speed. And as per certification, we have to choose the worst scenario, and as per certification, they have to consider the CG forward, the worst scenario. CG far forward, okay, to get to the worst scenario regarding the stalling speeds or minimum control speed. This one and this one, they don't limit. Sometimes the stalling speed and minimum control speed. So having that said, we have the normal envelope of the airplane with normal CG rent for certification is far forward. Okay? That's the standard for all the airplanes worldwide. 777, 737, Embraer, Airbus, everyone has to follow this rule. Everyone. So what Embraer did? Test pilots went to the authorities, ANAC, FAA, EASA, assim, I want to certify a new CG for takeoff. So-called alternate CG. We're gonna get these parameters and bring the CG aft. And we will certify, we will prove, we will show to the authorities that we may get a different stalling speed and a different minimum control speed for this envelope, keeping this safe. And Embraer spent a lot of money to certify the alternate CG. It's kind of variation of the part 25. And we certified it. And what is the advantage? Let me explain. Let's go back to the school. Whenever we have a CG forward, okay, we have to have more force on the elevators to counteract the CG position. Okay, and as you have more force on the elevator, you increase drag. If you increase drag, you increase stall speed. If you increase drag, you increase fuel consumption. Okay? Yeah, we learned this at school. So what is the advantage for alternate CG? This is the Embraer ePerf, okay, that I have on my iPad. But if you calculate, you cannot calculate because you select the standard, the alternate CG as a standard.
Yeah.
Yeah, okay, but on the Embraer ePerf, I can compare standard CG with the alternate CG. And what is the advantage? Look at here, maximum takeoff weight in normal CG, and the maximum takeoff weight for alternate CG. Okay, the payload, you can carry more payload with alternate CG. That's the advantage. Okay, for the same condition, same airport, Tashkent, 40 degrees, it's a high airport. With normal CG, standard CG, we may take off with almost 55. With alternate CG, 56. Okay, with takeoff 3, no flex. Takeoff 3, flex 42. Okay. That's the advantage to get the alternate CG. Okay. And for fuel consumption, it doesn't have anything regarding alternate CG, but just that's why I told you to try to push the zero fuel CG and the takeoff CG as aft as possible, only to save fuel. There is nothing to do with alternate CG. You know what I mean?
Yep.
The alternate CG was to increase the workload or the payload. Okay? And the fact that try to bring the CG, the takeoff CG and zero fuel CG as aft as possible is to save fuel. Only to save fuel, right? To offload the elevator force to counteract the lift and lower the fuel consumption. It works for the E2 and for the E1 as well. It's the same rationale. If you do this way, you are saving fuel. Always, always. And to sum up the presentation, I will give you some good tips, right? The first one is for FMS position computation. Nowadays, since 3 years ago, since the Russian-Ukrainian war, we are facing many problems regarding jamming and spoofing worldwide. I guess you fly to India sooner, right? Then there you will face this problem, for sure. In India, close to Turkey, anyway. So, we have an FOL. No, it's an OB, sorry. It's an Operational Bulletin from 2024-002. I suggest you to read this OB. It's really important because we have some procedures whenever you face spoofing or jamming. We have to cope with some procedures on the FMS. And there is another statement on the doc, ICAO doc 9613, it's regarding performance-based navigation. It states there that we have to verify the aircraft position if it was entered correctly. We know that on the E2, on the E1, the FMS, the GPS will insert the position automatically. That's why we saw the airplane destination airport already selected on the FMS. But it's up to us pilots to check if this position is correct. That's why we have on the airport charts the coordinates for every gate. And that's why we have a plate in front of us in yellow, maybe in yellow, with the coordinates. So what I suggest, this is not written on the SOP in Embraer, but it's written on the regulation. What I suggest, before loading the flight plan, we have to check the navigation database, if it's valid. Remember the data, it's valid. After that, go to the position sensors and check the position regards against the position that the FMS is retrieving. Doing that, you ensure that the FMS load the correct coordinates for the navigation. Especially, this procedure is really important, especially if you face some jamming and spoofing after the flight. Okay, it's a suggestion. So let's talk about tires, brakes wear, and APU fuel consumptions, which means spend money. Company spend money as well with brakes, tires, and APU fuel consumption. So imagine that we are landing here in Ulaanbaatar with this weight, and the auto brake in low gives me 2,123 meters to stop the airplane, letting the auto brake acting until a complete stop. But normally, I will press the brakes before, okay? On this condition, this situation, is it feasible to vacate via Charlie? I have 1,800 meters. If you touch on the touchdown zone mark, it's feasible. It's feasible. Really feasible. I'm not talking about press the brakes with a strong force. I'm talking about normal brakes usage, okay? It's feasible to vacate on Charlie. What we have on this engine is quite normal. This rationality that I'm talking here right now, it's quite normal on the operators. That's why I'm here, so let's try to give you some suggestions to save tires and brakes. As we have on this airplane to wait 5 minutes to cool down the engine before shutting down. If I don't have any restrictions on the airport to stay on the gate with engines running, do I have any restriction here? Because of noise, something like that? If you don't have any restriction, you may vacate on Charlie, park at the gate, and wait 5 minutes at the gate. You are saving tires and brakes wear. Why do I have to choose vacate on Alpha, to choose a long path, a long taxi, you know what I mean? It's because of the engine. There's no reason for that. You are wear tires and brakes. Unnecessary. So you may elect the next taxiway feasible for you. Needless to worry about the engine cool down. Park at the gate. So we have to wait 3 minutes. Wait 3 minutes at the gate. And you are saving tires and brakes. Okay? And regarding APU fuel consumption, I did a calculation for every minute with APU running. In a year, we spent 6,700 kilograms of fuel. 1 minute. I see some pilots vacating runway, so turn on the APU. no reason for that. And stay with APU running 3 minutes. Okay? The APU takes around 50 seconds to come on the line. Before entering the gate, what I do, before asking for taxi light off, I ask for turn on the APU. When you stop the airplane, the APU is on the line and you can shut down the engine and you save fuel from the APU. If you are on the E2, as we have the 5 minutes cool down, if I park the airplane at the gate and I have to wait 3 minutes, APU off. Needless to turn on the APU. 1 minute before, shut down the engine, APU on, with the airplane parked, APU on the line, 5 minutes, shut down the engine. You are saving fuel. Okay. On the E1, as we don't have this limitation for 5 minutes, when I getting close to the gate, before entering the gate, turn on the APU. Takes around 50 seconds. Suggestion, just a suggestion. Engine reverse usage. Do you know that there is a combination between the auto brake usage and reverse, right? Auto brake is set for a constant deceleration rate. You know that, right? On the ground school. If you are using low, for instance, the auto brake will decelerate at a rate of 6 feet per second square. If you use the maximum reverse, the auto brake will release the pressure so as to keep the deceleration rate. Okay? That's the rationale. Having that said, guys and lady, do we need to apply maximum reverse for dry runways? No need to do that. No need, only minimum. For dry runway, only minimum reverse. And doing that, you are saving engine life as well. The temperature on maximum reverse on the ITT, on the E2, goes up to 790 degrees. It comes from around 560, 600 to a peak of 780 to 90 degrees. And I see many pilots, not here, worldwide, landing with on a dry runway, long runway, and using maximum reverse unnecessarily. Maximum reverse is really important, and it's a must if you are landing on a wet runway or a contaminated runway. So there's no discussion regarding this. Go to max. Yeah, but on dry runway, needless to do that. Only minimum reverse. And try to state it on the briefing or on your descent briefing, approach briefing. So configuration for landing is going to be minimum reverse, auto braking low, flaps 5, in case of go around flaps 2, flaps 4. But keep this point, state this point during the briefing so as to keep your mind that you're going to use minimum reverse for dry runways. Okay? And another, just to standardize your procedure as you are flying a mixed fleet from E1 and E2, and we do have a limitation for this reverse. You may use the reverse in case of reject takeoff, in case of any situation that the safety is a concern. You may use this reverse until a complete stop. You can use it. For safety, you can use it. Okay? Okay? But we have a limitation. You have to go to idle at 30 knots at least. But there is a statement on the AOM that using reverse below 60 knots, you may increase the foreign object injection. What I recommend to you guys, if you don't need to use reverse to stop the airplane for safety concern, when I hear the call out 60 knots from the monitoring, stall the reverse. Not in idle, stall the reverse. Stall. 60 knots. That's why we set on the ePerf, on the SOP, 60 knots for reject takeoff and for landing as well. Nowadays it was an update on the SOP, on the Embraer SOP. We had only for reject takeoff the 60 knots. For normal landing we didn't have at the beginning. And we updated that 60 knots during the landing. Whenever you hear this call out, pilot flying, stall the reverse because of this statement here on the manual. Okay. And another good point to be discussed is, let's say a hypothetical situation, you are taking off and at around 120 knots, the tower say that the runway is blocked and you reject the takeoff. Okay? You reject the takeoff. Auto braking max, and we are subject to startle effect, right? We are human beings. And we forget. Because of this situation, it's a rush situation, we forgot to stall the reverse. We went to a complete stop with reverse applied. Okay, so idle, let's assess the situation, tire brakes, the tires is good, everything is good, I can do another takeoff. Let's reposition. The ATC told you, would you like to do another takeoff? You can go, the runway was only a car, anything. Can we take off again? No. This engine has a limitation. No. On the GE, on the U1, you can. This airplane, no. Whenever you reject the takeoff and overshoot these parameters here, we cannot do another takeoff. I have to go to the gate, call the maintenance, and they have to inspect the engine. If you are in doubt, if you use the reverse below these parameters, let's take the most conservative way, call the maintenance. There is a limitation. On the E1, we don't have this limitation. On the E2, we have. Keep it in mind. Okay? That's really important. We are facing, since the beginning of the operation on the E1, we are facing some issues regarding this failure. Okay. It's more common than we expected, than the manufacturer expected. We already had 3 situations in Porter, 2 in KLM, 3 in Azur Lines. Okay, so the QRH was already reviewed regarding this procedure here, and the problem was whenever you have, especially the MAU 3 Bravo, we didn't have any failures on the brakes, but when you land and you try to apply brakes, you get brake fail, and you had to use the parking brake to stop the airplane. Nowadays, Embraer update the QRH procedure, stating just read and do. Just in flight, press the brakes. If you get engine brake fail, be prepared to use the parking brake. If you don't get brake fail, you have the normal brakes, just half, because you're gonna get the brake faults. You have the outboard or the inboard, I don't know by heart. But the procedure, the update procedure was to press the brakes in flight to check if the message will appear and to be prepared to use the parking brake for stop the airplane. Okay? And there is another good point. Whenever you have both either failures, we're gonna lose some ADS. Okay? 1 or 2. And because of losing ADS, sometimes you may lose the autopilot. The autopilot will be disengaged. Try to re-engage after doing the procedure. and you may fly the airplane without the pilot. Okay? Try to re-engage, because it failed just because of the ADS failure and sometimes reversion from the ADS, right? When you lose the ADS1, the ADS3 will power the PFD number 1, and you can lose the autopilot. If you lose the autopilot with this failure, try to re-engage it to make your life easier. And the root cause for that was some thermal damage on some points of the MEAU power supply. That was the root cause we already discovered in December last year, and we are working with the suppliers to send a new MEAU power supply, and it will be corrected until July this year. Maybe 1 month, 2 months ahead. It will be probably Honeywell will get this new power supply to replace the power supply and to get this problem solved. But we are facing this situation, and I do recommend there is a OB issue regarding this failure, since sometimes we can we may use the parking brake to land the airplane because you're going to lose brakes, so as not to keep the airplane on the runway. This OB state a procedure to recover half of the brakes so as to allow you to go to the gate. It's on this OB. I suggest you to maybe to send to the pilots. It's good to know what is the procedure regarding this OB. Okay, you may vacate the runway if you are going to a busy airport like Delhi, Osaka, so as not to get the runway blocked. You may go to, so as not to ask for toll, right? You may go to the gate using the procedure stated on this operational bulletin. Okay? It's a good point. And at last, to finish, I don't know if you already heard about these conferences. Every year, Embraer organize the AOC, it's an operators conference, and a safety meeting as well with all operators. If you have chance to send one pilot, someone to this conference, is pretty good. You can share many information with many operators worldwide. Embraer always bring good information, good updates regarding the future, the fleet. It's really, really useful. Maybe if you have conditions, right? Honeywell has conditions to send someone, some pilots, some instructors to take part in this event. It's a really good point. It's really useful. And on the AOC, we have two meetings, two separate meetings. One for operations, for pilots, and the other one for technicians, for maintenance. We have two separate, on the same place, on the same date, the same week, but two separate meetings. Focus on the operations and focus on the maintenance. If you have opportunity, it's useful and recommended. So, any questions regarding all the points that we covered here? If you have any other?
Not so far.